But in this video, we're going to compare the effects of volume and osmolarity on the blood from the actions of aldosterone and antidiuretic hormone. We know that aldosterone works to increase sodium reabsorption from the filtrate, and as a result, water is going to follow. Such that the total blood volume is increased. On the other hand, antidiuretic hormone works to increase the number of aquaporin channels at the plasma membrane, so it only works to increase water reabsorption from the filtrate back into the blood. So now let's take a look at the effects of volume and osmolarity. If you take a look at the effects of volume, we know that aldosterone is going to increase the total blood volume because there's more water reabsorption that is happening. However, what about osmolarity? Osmolarity is defined as solute, the amount of solute per solvent, or osmoles per volume. So with the actions of aldosterone, we're going to increase the osmolarity of your blood because there is an increased amount of sodium reabsorption which is happening. However, you're also going to increase the volume because as sodium reabsorption occurs, water is all going to follow sodium into the bloodstream, so you're increasing the total blood volume. But because both the osmoles and the volume is increasing, and they're proportional to one another, there's actually going to be no change in the osmolarity of the blood with the actions of aldosterone. So the volume of your blood will increase, however, there will be no changes in osmolarity. On the other hand, if you take a look at antidiuretic hormone, we know that antidiuretic hormone is going to increase water reabsorption in the collecting tubules. So the volume is going to increase. The volume of blood increases with antidiuretic hormone because we're reabsorbing more water into the bloodstream. And now if we take a look at the osmolarity, osmoles per volume, the osmoles do not increase. We're not reabsorbing any more sodium or potassium ions. We're simply increasing the amount of water reabsorption that's occurring. So the osmoles stay the same, but the volume is increasing. And because this is a ratio, we're actually going to be diluting the blood because water is getting reabsorbed and we have more volume, but nothing is happening to the osmoles. So there's actually going to be less solute per solvent because we're increasing the volume of our solvent, such that there's going to be an apparent change in the amount of osmolarity because there's going to be less of this apparent sodium ion. So just to recap, antidiuretic hormone is going to increase the total blood volume, and it is going to have a decreasing effect on your osmolarity, such that it will appear that the blood is more dilute. Aldosterone, on the other hand, is going to affect the volume because it is going to increase the total blood volume. However, it will have no apparent effect on the osmolarity because both the number of solutes per solvent is increasing. Therefore, the ratio remains constant.